Hey, we are in Scale Drawings and Models number 1, Unit 5, Lesson 11. We are almost done with Unit 5. Students will be able to use a scale to calculate actual or model amounts. Students will understand what scale factor is. A scale drawing or a scale model is used to represent an object that is too small or too large to be drawn or built at actual size. A scale drawing is a proportional two-dimensional drawing of an object. A scale model is a proportional three-dimensional model of an object. So a scale drawing would be flat on paper like a blueprint. A scale model would be three-dimensional that would come actually like off the page or off the countertop. Often we do them for buildings. The measurements in a scale drawing and model are proportional to the measurements of the actual object. The scale gives the ratio that compares the measurements of the drawing or model with the actual measurements. So if we put the drawing distance on the top, let's say we draw something that's 1 inch, it would represent an actual distance of 10 miles. We can also write it with a colon. Every 1 inch is worth 10 miles. Use the provided map of the United States. So you have a map of the US that was provided for you. And we're going to say, well, what is the scale? We would measure in centimeters. So the scale is usually on some sort of key. So in this case, we have a key right here. And if we measure this, you can see this says 300 miles along the bottom. So however long this little segment is 300 miles. And that segment is actually 2.5 centimeters long. So we would say 2.5 centimeters for every 300 miles. We also can write it as a fraction, 2.5 centimeters for every 300 miles. Use the map and your scale to find the distance in miles between each pair of state capitals. So from Phoenix, Arizona to Boise, Idaho, if we measure using a ruler, that is 6.4 centimeters. So if I use a proportion, every 2.5 centimeters is worth 300 miles. That is equivalent to 6.4 centimeters being worth X miles. I'm going to solve this proportion using cross products. So 300 times 6.4 equals 2.5 times X. That's going to be 1920 on the left when I simplify. Divide both sides by 2.5, and I'm going to get 768 equals X. So that means if it's 6.4 centimeters on the map, it is approximately 768 miles in real life. Now that's as the crow flies. That would be a straight line. That's not necessarily taking into consideration if the roads make it longer. Now from Helena to Bismarck, that's going to be 4.6 centimeters on the map. So we would set up a proportion again, 2.5 centimeters for every 300 miles equals 4.6 centimeters to X miles. And we would use cross products. 300 times 4.6 is equal to 2.5 times X. If I multiply these two numbers on the left, 1380 equals 2.5X. This is multiplication, so we would divide on both sides and get 552 equals X. So that means on a real trip, as the crow flies, approximately 552 miles from Helena to Bismarck. If we go on to the back, how do we find a distance in a model? The liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of Earth has a scale of 1 inch to every 500 kilometers. How thick is the liquid outer core of the model? So for every 1 inch of the model, it's worth 500 kilometers. How many inches would it take to be worth 2,300 kilometers? So we would do the same thing, cross products, right? So 1 times 2,300 is just 2,300 equals X times 500 or 500X, and divide both sides by 500. And we would get 4.6 equals X. So that means 4.6 inches thick on the model. The mantle of Earth is 2,900 kilometers thick. That's your actual, right? That's not on the model. So that's a number that's going to go on the bottom. So for every 1 inch on the model is 500 kilometers of thickness. How many inches, X on the top, right? Our model thickness goes on the top. Will it take for 2,900 kilometers of actual thickness? So we would cross products. 1 times 2,900, nicely, 2,900, equals 500x, and divide both sides by 500. And you would get that x is approximately 5.8, or we can say 5.8 inches thick on the model. So it's just a matter of keeping your numbers straight. We've got the model thickness on the top, actual thickness on the bottom, and solve with a proportion. Finding a scale factor. A scale factor can be written without units when the units are the same. A scale without units is called a scale factor. A scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet. So for every 10 inches, it's worth 100 feet. You could also say that every 1 inch is worth 10 feet, like putting it in lowest terms. Another way to write that would be every 1 inch is 10 feet. Now, what if we get the units the same? Instead of 10 feet, we could multiply by 12 and say every 1 inch is worth the same as 120 inches. Once the units are the same, it's a scale 1 to 120. Every 1 unit on the model is worth 120 units in real life. The real monument is going to be 120 times taller than the model. What is the scale factor of the model? So that's what we're talking about here. That's your scale factor. Another way to find it would be to say we have 10 feet, right? This is the 10 feet. Remember how I told you to multiply by 12? What's really happening is we're multiplying by the fact that there are 12 inches in 1 foot. I can cancel the feet. 10 times 12 is 120 inches over 1. It's just another way of finding the answer if you didn't know that you could just multiply by 12. A drawing has a scale of 1 millimeter to 20 centimeters. What is the scale factor? So every 1 millimeter is worth 20 centimeters. So how can I get those so that they are the same units? So I'm going to write the 20 centimeters. I'm just going to put it over 1 so it looks like a fraction. And I'm going to multiply by the fact that every 10 millimeters is worth a centimeter. So this is a unit rate, right? Every 10 millimeters is worth 1 centimeter. Sometimes we also call this a giant 1 because it's only worth 1. Every 10 millimeters is worth 1 centimeter. My numerator, my denominator are the same. I can cancel out the centimeters. 20 times 10 is 200. So 200 millimeters. Another way to write this would be that every 1 millimeter is worth 200 millimeters. Since the units are the same, it's a 1 to 200 scale factor. This is a little tricky, so make sure that when you are in class, you're asking questions about scale factor.